Hey guys, welcome. This is our 1.3 video. Again, at the very top of the page, probably bigger, you want to write 1.3, measuring segments. Our objective today is to find and compare lengths of the segment. You don't have to write the objective if you don't want to, but if you want to, you can. Alright, let's go ahead and get started into our vocab. And our first thing we're going to talk about is this right here. This is just called the Ruler Postulate. I'll just read it to you guys real quick. It says every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on a line and the real numbers. The real number that coordinates to a point is called the coordinate of a point. I'm not going to have you guys write this down, but we basically say a coordinate is going to have some sort of length, and we can compare it to a ruler. That's kind of where this postulate comes from. Okay? Because of the postulate, we're allowed to measure lengths of segments. So this is our next vocab. The distance between point A and B is the absolute value of the difference of their coordinates. So I'm actually going to have you write that out right there. So write that sentence there. This value is also AB, or length of AB. So distance from here to here is the absolute value. Distance cannot be negative. I can't say my house is negative 10 feet from your house. That'd be impossible. To find how far apart, we use subtraction to find the difference, but then it has to always be a positive value. That's why we use absolute values. Okay? Alright, so make sure you have distance down. We didn't need coordinate down. Okay, let's continue to move on. Alright, we do need this one. This is a huge, huge concept. You're going to see this all over the place. And this is called the segment addition postulate. This is a great name for it because it just means if you add two smaller segments together, it should make the full segment. So we definitely want to write this whole box. If you take AB and add it to BC, you should get the full segment of AC, and here's that equation right there. So it kind of makes sense, right? You add some piece to another piece, it makes a bigger piece. And that's all that segment addition postulate is about. We're going to use algebra mixed in with this. So here's our kind of memorization piece, and then we're going to go ahead and apply it in an example in just a second. Let's continue on with more vocabulary on the next page. As you can see, this is straight from the book, so I kind of like to use this online book to help us. So if you want to follow along in your book too, you can. Alright, next we get into our first piece of congruency. So if two segments have the same length, so we can write this down, two segments have the same length, then those segments are congruent segments. Okay. Down here, AB is 1 inch, CD is 1 inch. That means they have the same length. That means they are thus congruent. We can actually draw little congruency marks just like this. And to show congruency, do you see how instead of an equal sign it has that little like, that means my segments are congruent. So this means they have equal length. This means that they are congruent. Okay, and when we get into proofs, we go back and forth between those two. But one equal sign has to do with actual measuring the length, and the other one is saying that they are congruent segments. They're equal to each other. So that's kind of the two differences there. So make sure you write those down. And if I were you, I would definitely draw this picture right here. Okay? And moving along, moving along, moving along. Alright. Another huge piece is the midpoint, and we also sometimes call it segment bisector. So I'll read this real quick. The midpoint of a segment is a point. It divides the segment into two congruent segments. Okay? A point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect. So bisect is like cutting it right in half. A lot of times I'll say, I cut you right in half, you'd be bisected. The point, line, ray, or segment is called a segment bisector. So I would go ahead and write all of this, and I would also include the picture. Okay? Boom, boom. So this is showing right here that AB and BC, those are our congruency marks. They're showing that those two pieces are congruent to each other, which is going to be very valuable to us as we're trying to set up and solve equations. Alright, I think we got one more piece. Nope, that was it. Alright, let's jump over to our first question. So let's go ahead and make sure we write this one down. This is our first example. Write this and write this. What are UV and SV on the number line? So this is basically what is the length. So we're trying to find distance. So UV, we have two ways we can do this. We can count, or we can use that subtracting and using absolute value. Notice my number line is going by 2s, so I got to be careful. So U to V is going to be 2, 4. So I jumped 2 each time, which gives us a total of 4. So the length of UV is 4. SV, they're further apart, so instead of counting, I'm going to say the absolute value of -4 minus 14. Okay, so if I take the difference between the two numbers, doesn't matter the order because it's going to come out absolute value. They're both negative here, so we're going to actually combine them. So it's like I took $4 from you and I took $14 more from you, which means I've taken a total of negative $18 from you. But then the absolute value, distance cannot be negative. We get SV is 18. And there it is. So we got our 2. So we can count, or if it's a little bit further away, sometimes it's faster just to go ahead and use that absolute value trick that we took our notes on. All right, let's go to our next problem. All right, in the diagram, JL is 120. What is JK and KL? Okay, so again, geometry is kind of different where not only are we doing algebra, but we have to set up the problem. So it's like we have these little word problems every single time. So this is our second example here, and I like to mark out where is JL. So JL will go from here all the way to here. So this is the full segment of JL, and that's 120. So algebraically, how could I create an equation out of this? Well, this is our segment addition postulate. It means the small segment plus the other small segment should equal the large segment. Okay, so we're going to take 4x plus 6, that's our smaller segment, we'll call that JK, plus KL, which is 7x plus 15, and that should all equal the full length, which is JL. Okay, so this is our segment addition postulate. Too small, add up to make a large. So we're going to go ahead and combine like terms here. 7x and 4x are going to make 11x. 6 plus 15 is going to make 21, equals 120. Okay, switch letter colors here. Subtract 21 from both sides. We're going to get 11x equals 99. And then we're going to divide by 11, and x equals 9. Again, basic, not too intensive algebra there. We had to combine like terms, and then it became a two-step equation. So pretty basic. So we get x equals 9. We're not done yet because it asks us what is JK and what is KL. So you always got to read the question carefully because I thought I was done. I am not. So we got to plug it back in. JK is 4 times 9 plus 6. So 4 times 9, that's 36, plus another 6. That's going to give me 42 for JK. We could say line segment. And KL is going to be 7 times 9 plus 15. So 7 times 9 is 63, plus 15 is going to be, what, 78, I believe? And then we can do a real quick check. I have my calculator, no shame in doing that. We can go ahead and add 78 and 42. And what should happen, if you can kind of see on my screen, 78 and 42, they do make 120, which is the full segment length. So I'm pretty sure I got this one right. All right, let's look at the next one. Okay, so this is our third problem here. Now, I want you to notice that this problem looks very similar to the last problem I just did. And you're going to have kids that are going to make mistakes between these two, but our key word here is midpoint. Okay, midpoint means that these two are congruent. If I know things are congruent, it means I can set them equal to each other. Okay, the last problem, those segments, they were not congruent segments. One was 42, one was 78. Okay, we just knew what the total distance was. So you got to be very careful. Here, I don't know the total distance of PR, but I do know that Q is in the middle, which makes it two congruent segments. So I can actually set these two equal to each other. Okay, and I'm just using vocab to help me look at a picture and come up with an equation. That's the majority of what we're going to be doing in geometry. Okay, so we got an equation. I'm going to go ahead and use my algebra skills. I know I'm going to move the smaller x first. Makes my life easier. Okay, we get x minus 7 equals 1. I'm going to add the 7 over, and that's plus 7. And we get x equals 8. Again, I don't want to stop here because it asked me to find each piece, right? So I'm going to actually go ahead and plug those back in. I'm going to do this a little bit faster. I'm just going to kind of do this a bit in my head. 6 times 8 is 48, and then we're going to subtract 7. Now, if you're worried, you can always use a calculator just to verify. I'm looking for you guys to kind of make sure you're precise here, so I'd rather you be able to set this up and just double check with your calculator. So I'm just double checking. I did get 41, so that is correct. So PQ is 41. QR, 8 times 5 is 40, plus 1 is 41. Again, I'm just going to double check. I make mistakes too, so it is 41. This is good news for us, right? If they weren't both 41, would these be congruent segments? No, and we treat them as congruent segments. Add those two together, and our full length should be 82. Okay? All right, let's go ahead, and I think that might have been the last one. Let me check. Okay, yeah, that's our last problem. So there you go. Again, midpoint and segment addition postulate are two things that we kind of mix up a lot. So anyways, we'll see you guys, and hasta luego. Goodbye.